Hello students, I am Dr. Noor Danish, working as Assistant Professor in Department of Physics, Jamshedpur Cooperative College, Kolhan University. So in my previous lecture, I discussed about the phase velocity. Today, I am going to discuss about the group velocity. Now, when we were discussing about the phase velocity, we came to conclusion that phase velocity can be greater than the velocity of light, which was, which I told, is only a mathematical concept. So let's see whether the particles are moving with which velocity in the waves 10. So for this, the group velocity concept was defined, and the salient features of this group velocity are assumption. It is assumed that each moving particle of matter constitutes groups of wave. Now I am not calling it a wave packet rather than a single wave train. So the assumption is that it is a group of particles producing slightly different frequencies and they are traveling in the same direction. The mutual interference between the component wave results in the variation of the amplitude. So there is a mutual interference within the different component and define a shape of the wave packet. So this mutual interference is defining what will be the shape of the wave packet. Third, the component wave interfere constructively over a small region of space, outside which they interfere destructively and thus reducing the amplitude to zero. So with this assumption, your waves will be looking like this. Okay, primary wave means wave having increasing amplitude and then onward decreasing amplitude. So within this constructive interference is happening and the destructive interference is leading to the amplitude to zero at the point of C. Now, and A was the point of starting of the wave. So A and C can be called the point of minima and the B will be called the point of maxima. This is the point B and this is the point A and C. Okay, so these are the points of minima. Now, the group velocity is the velocity. That's what we define. The group velocity is the velocity with which the slowly varying envelope of modulated pattern due to a group of wave travels in the medium. Means here how the waves pattern is moving as an envelope is defining the group velocity, and it is the velocity with which, this is also the velocity with which the energy in the wave group is transmitted. Means how the energy get transmitted also. Let's see it mathematically. We consider two wave trains A sin omega 1 t into k2x and another train y2 is equal to A sin omega 2 t minus k2x. These are the two sine waves. Okay, and the resulting amplitude of them will be y will be equal to y1 plus y2. Now, when we put this value of A and B, we will get y is equal to A bracket sin omega 1 t minus k1x bracket close minus sin omega sin bracket omega 2 t minus k2x. And when we expand this can be considered sin A minus sin B. So it can be expanded and this expansion will give me 2A cos omega 1 minus omega 2 t upon 2 t in minus k1 minus k2 upon 2 x. And now which can, and the sine component will be sin omega 1 plus omega 2 by 2 t minus k1 upon k1 plus k2 upon 2 by t. Now this whole component will be acting as an amplitude. Okay. Now consider omega 1 plus omega 2 as a 2 by as omega and k as a k1 plus k2 by 2 delta omega as omega 1 minus omega 2, and the K2 delta K will be equal to K1 minus K2. This equation can be simplified as y is equal to 2a sin omega t minus kx and cos delta omega upon 2t minus delta k upon 2t. Now, there are two parts of this component. The first part is this one. Okay, from this one we had defined already a value called phase velocity, and u will be equal to omega upon k, and in terms of linear velocity and lambda, 2 pi v upon 2 pi upon lambda is equal to v into lambda. Okay, nu into 2 pi mu to 2 pi into mu into lambda, and that will be defining me the phase velocity. The another component which is coming from here, okay, g will be defining as delta omega upon delta k, and we have defined delta omega as omega 1 minus omega 2. So omega 1 minus omega 2 upon k1 minus k2. It represents a slowly moving envelope of frequency delta omega upon 2 and propagation constant delta k upon 2. What it is representing? A slowly moving envelope. Okay, this envelope is represented by dotted line. Here see the dotted line. Okay, this is represent the dotted line in the curve and move, and the velocity of this will be g is equal to omega 1 minus omega 2 upon k1 minus k2 is equal to delta omega upon delta k, and is defined as group velocity. Since group contains number of frequency components, okay, in a very small frequency interval, I said different particles moving with the different velocity, and hence they will have a different in the frequency. G will be equal to delta omega partial differential of d omega upon dk, and which will be equal to in terms of velocity and lambda square del v upon del lambda, and this is the expression for the group velocity. So see, group velocity is always smaller than the velocity of light, because there was a constructive interference as well as a destructive interference, and the amplitude was reducing to 0 at the point of B, point of C, and thus in this lecture you understand the group velocity. In the next lecture you will be understanding the relation between the phase velocity and group velocity. Thank you for listening.